Tech Revision with Mrs. Swanee Pooh.
Hi everyone, this is a very quick video to go over chapter 28 in the revision guide, which is all about design communication. So this is a funny little chapter in the book. A lot of it is common sense, but there are some things that I wanted to go over just to make sure nothing catches you out. So what are the things that you need to know? You need to know what design and technical reports are, which are basically your stuff that you've done in your NEAs. You need to know a few of the different types of graphs, tables and charts. You'll know all of these from GCSE maths or other subjects. All the different types of 2D and 3D drawings. Some of them are so easy it's ridiculous, but we'll go through all of those. And then there's something called dimensioning and details for manufacture, which is basically a standard set of symbols that are used on things like technical drawings, like orthographic drawings. So we'll have a look at those quickly as well. So this is the first section in the book. It's called Design Reports. And basically a company might produce a design report to give an overview of the project. They might do a bit of an introduction that explains what the design problem is, the context. So just like the context page that you wrote in your NEA. They might give details of clients and possible customers. And they might give a selection process used to choose the final design. Well, that very much sounds like a specification. So you can see that a lot of this is similar stuff to the kind of like research section, introductory section of your NEA. The conclusion then would be, why you chose the design you chose. Look, evaluation against the initial spec. You did that in your NEA. Also suggestions of modifications and testing methods used. So you can see that bears a lot of resemblance to a lot of the stuff that you did in your NEA. Then we have something called a technical report. These are used to record practical test results, market research, and review products relevant to design development. So that's product analysis. So again, this is all stuff that you will have done in your NEA. Things where you did material testing, you might have done some research into particular target markets. Not many of you did that really, but you may have done it in other subjects where you've used things like bar charts. I know geography students use those a lot. And you would expect to see things like data, graphs and charts. So I'm not going to talk any more about that. That's about as difficult as it gets, but these basically refer to a lot of the stuff that you did in your NEA. Some of the other things you need to know. You need to know what a bar chart is. You would have been using these since primary school. So a real simple way of representing data. They're used in many different types of reports and quite often in the media, and they're very commonly used, easy to understand. Bar charts, there we go. Pictograph, so it's very, very easy to understand, very quick to read. It's quite good for presentations because it's quite visual, but the problem with it is it's not very accurate. So you can see that you've got more of a picture than an X and a Y axis, which might give you more accurate data. So that's a pictograph. Then you've got a histogram. Bear in mind that this sometimes comes up as a maths question in the paper. They are similar to a bar chart, but they use ranges of data and they show the frequency distribution. So if you're not sure about a histogram, you need to go and watch the video that I asked Miss Baker to record, basically answering a histogram question from the exam paper. So go have a look at that, it's on my channel. Next few that you need to know, a line graph. What's nice about this is it shows data changes over time. So you've got like time at the bottom and you can see the changes. It's very easy to understand and it uses scales, so it's quite accurate. Pie chart. You can obviously see the data distribution really, really clearly. The size of the segments is proportion to the data, very easy to read and understand. And then you will have seen stuff like this before, data tables. Quite often in product design, you might see anthropometric data presented like this, especially in that little book that I've got in the department. It enables you to identify patterns because you can see all of the data. And it's used quite often in like cutting lists, costings, and like I said, anthropometric data. So that's a data table. Right, different types of drawing techniques now. So this one is orthographic. You all had to produce one of these for your NEAs. There's actually two different types. There's one called a first angle and a third angle. We often use this third angle system where you've got the front, the top or the plan, and the right side view. But you can see the first angle system just kind of has the angles in different positions. And that's just a way that they're done. So a company or a business will choose to use one or the other, and they will most likely stick with that to ensure consistency across the manufacturing process. So they are used by engineers and manufacturers. You wouldn't give an orthographic drawing to a client really, because it's not showing them the aesthetics or the style or the function of the product. It's showing the manufacturing details. So it's showing things like dimensions and hidden details and all the little things that are necessary to be able to manufacture the product. So building on that, a sectional drawing is basically a cross section. So sometimes on a drawing you can see lines like this that go through a component, and then it will say, look, this is what it looks like if that was a cutting plane. This is what the inside of the product would look like. And it can show you things like, you can see there's a little bit of a kind of a recess there before the whole carries on all the way through the product. So sectional drawings show internal details, and the hatching is used to indicate where the material is solid. And then you can see things like internal details, and remember these dotted lines on orthographic drawings are hidden details. Another thing just to bear in mind as well is that when a circle is drawn, you always have this line that goes through the middle to show the center of the circle, and then usually a dotted line across the top and the bottom to show basically the top and the bottom of the circle. So that's a sectional drawing. It's like a cross section used again on technical drawings. This is what I was talking about, the dimensioning and details for manufacture. So this is the kind of drawing that might be given to someone who's going to create a mold for injection molding, or someone who's going to manufacture a prototype or something. Imagine this is the lid here in 3D, and then you can see this is the technical drawing. Now all of these really complicated looking details all around are standard symbols that are used, and they are called geometric dimensioning and tolerancing, so GD&T. So that is a standard set of symbols that are used on engineering drawings, and they're standardized across the world so that you can send a drawing that has GD&T anywhere in the world and it would be manufactured correctly, because they would understand what the symbols mean. So for the exam, you do not need to know all of this stuff. You don't need to know it, but it might be good to have an awareness of geometric dimensioning and tolerancing as a good way of controlling quality, as a good way of ensuring accuracy, because they show dimensions as well as tolerances. Remember, a tolerance is a plus or minus, and then you would give some kind of measurement to say the part can be plus or minus whatever, and it would still be, a functional product. So you can see here, there's a diameter of 37, and then there's a plus or a minus, and it gives you a tolerance, okay? So there we go, that's what that is. Right, we're going to whiz through these really, really quickly now because they're dead easy. Make sure you have an awareness of what isometric drawing is. You've got the 30-degree angle at the bottom. It's used to sketch designs. It can be freehand. It's quite accurate, and it gives quite a realistic view of a product. When you actually start drawing more complex shapes, this is actually in the book, it's called crating. And I usually do teach you to do that. If you're struggling to draw something in 3D, you might first create a crate and then create the shape kind of inside the crate to give it a bit more accuracy. So that's called isometric crating. Next one-point perspective. It's often used by architects, interior designers. It gives the drawing depth, so you can see it's been used on an interior design here. All of the lines are going back to the vanishing point, apart obviously from the vertical lines. The issue with this in terms of product design is it makes products look a little bit sort of stretched. and a little bit larger than they maybe are. But it's quite a good technique, like I said, for architects and interior designers. Next one is 2-point perspective. It actually exaggerates the 3D effect. So where isometric, everything is parallel to each other. 2-point perspective, you can see the lines are not parallel with each other because they go back to the vanishing points. So it gives quite a stylish kind of look to design work, and you can actually draw the product above or below the horizon line, which gives quite a different sort of effect. It can make products look quite big, slightly unrealistic, but is very stylish, eye-catching, a good way of presenting design work to clients. Okay, so this is actually in the book, which I didn't realise, but using different thicknesses of lines on drawings to make certain areas stand out. So, like I've said before, you might have your design, and you might do a thicker line around the outside to give it more depth and keep the lines on the inside thinner, and it just kind of helps to make the drawing, I don't know, like stand out, look quite cool, bit of flair. That's it really, but you can see the technique is used predominantly all over the design industry to present drawings. Trying to go as quick as I can now. Marker rendering, so spirit-based markers are used. They're normally alcohol. Can I spell alcohol? Yeah, I should be able to. And they normally need to be used on marker paper, which is bleed-proof. So just a good thing to remember. They provide a base colour, additional layers can be added. You might use a fine liner then to add more detail, and it just enhances the realism of drawings. Okay, this one's a little bit old-fashioned because this doesn't happen as much anymore, but you might say that mixed media drawings would be a combination of things like fine liners, markers. You very rarely will see anyone using watercolour or anything like that. Pencils, but what you might see people do is use things like Photoshop. They might use Procreate to take their drawing and add colour actually on sort of CAD systems, on graphic drawing tablets, all that sort of stuff, to create a drawing that's got lots of different types of media on it. Last one, easiest left to the end. Yeah, you can create different textures. So you might want to do that on a presentation drawing to a client to give some indication of what types of materials are used. So this is a gloss finish, you can see on this product with that kind of highlight. You can see nice wood textures, and we've got stone, maybe concrete. So yeah, specific materials can be suggested, and this can be really useful for client presentations. Right, there we go. Managed to keep it as short as I possibly could. Just some things to bear in mind, could potentially come up in the exam. Right, see you on the next video.